we are going to discuss the working mechanism of topic models. For the sake of implementation, we'll be using the already built-in functions in the sklearn library. However, those of you who are interested in its workings, in case you want to implement it yourself or modify the algorithm, we'll just pass through its steps and see how it works. Topic models is a kind of soft clustering we already discussed. Need to be provided the number of topics which are the same as the number of clusters in clustering techniques. So in case we provide the number of clusters to be 2, the model is going to label our clusters as 0 or 1, or we can call them T0 and T1. However, the labels are not going to be meaningful as is the case with any other clustering technique. Next, we need to provide a stopping criteria. It can be the number of iterations if we assume that our model is going to settle down with good topics in these many iterations, or we can also provide tolerance as the difference between the values of 2 iterations, that if the difference is less than a certain value, then that is good enough and we do not strive for any further accuracy and the algorithm should stop over here. There are 2 hyperparameters with topic models that are called alpha and beta, and alpha is provided as input to the topic document mixture or distribution, and beta is provided as input to the topic word distribution. Now this can be a vector also where each document is treated differently for each topic. In the algorithm we will use from the sklearn library, alpha is considered as a floating point parameter. So only one value can be provided. We cannot provide the vector. However, if you implement it yourself with that, we can provide a vector of length documents. In other words, we can have a separate value, a dedicated value for each document, and that is going to decide how their document is going to be treated. If this value is high, then we are looking for fewer topics with more confidence, and similarly if this value is low, then we are looking for more number of topics with a mixed representation. Same applies to beta. We are going to have a separate lecture on what is the role of alpha and beta in detail. These are some of the variables that we have to maintain. Theta is the mixture of dt, where each value is going to represent the proportion of a topic in each document. Similarly, phi is a 2D array or a distribution of T to W, where each value represents the proportion of a word occurrence within a topic, and Z is the matrix that gives us a specific value, that is a topic label of a word occurrence within a document. Since we earlier decided that we are going to have 2 topics, therefore topic for each word occurrence within any document is going to be either 0 or 1, because obviously we have 2 topics. So if we assume a dummy dataset that has got 4 documents from D0 to D3, where D0 has 10 occurrences of the word bread, we are representing it with 0 just to simplify this representation. D1 is 10 occurrences of milk, represented by 1. D2 is 10 occurrences of chair, represented by 2. And D3 is 10 occurrences of milk and 10 occurrences of bread. Now we have frequently repeated the word so that out of this small data set we still would try to find good correlation between words. The first thing we are going to do here is that since topic models follows Markov approach, therefore we are going to assign a model any random state, and by any random state we mean that in the Z we are going to assign labels at random to each word occurrence in each document. In other words, we are going to say this word belongs to topic 0, this belongs to topic 1, 0, 1. Since we have only 2 topics, so each word in each document is going to be given a topic label which can either be 0 or 1 at random. So this is how we are going to give an initial state to our model. This initial state is given at random because we believe for higher number of iterations the model is going to correct itself by improving from one state to another, and the final end, irrespective of what our initial state is, the model is going to be good separation of words as topics when it reaches its final iterations. So this is a representation of our random initialization. These are the word IDs and these are the topic IDs. As you can see, we have 3 words in our vocabulary that are bread, milk, and chair. So their IDs are 0, 1, and 2, and we have 2 topics and we have given them labels as 0 or 1. So these are the actual word IDs and these are the topic IDs that we have assigned to these words at random. For example, the first word in the first document is given a topic of 0. The second word in the first document is assigned a topic 0. The third word in the first document is assigned a topic 1, and so on for all the words in all the documents. Next, we see theta as phi. Theta and phi is the 2D arrays or the matrices, and here eta dt represents the count of the topic T in the document D. So if we get back over here, the presence of topic 0 in document 1 is 5. We have 2 zeros over here and 3 zeros over here. Similarly, the presence or the count of topic 1 in document 0 is also 5. So this is what it means. What is the frequency of a topic in a document? And alpha is our constant that we saw earlier. T is our total number of topics, so that is 2, and alpha is our constant or hyperparameter that we give an initial value of 1.0. Over here we are iterating through all the topics for the given document, and this is basically a normalization factor, that out of the occurrence of this topic in this document, what is the occurrence of all topics in this document. So basically this is going to normalize for different sizes of documents, because obviously if the document is high, we are going to have more topics in it, and if it's a small document, then the number of topics occurring in their document are also going to be low. The same process is repeated for phi tw, and therefore eta tw means what is the frequency of the occurrence of this word in this topic. And again, these are the constants, and over here we are iterating through all occurrences of all words for the same topic. So by multiplying these two, we are going to get the probability of a word belonging to a topic by looking at the other occurrences of that word belonging to different topics, and by looking at the other words belonging to the same document, and this is going to give us a probability for a word within a topic. We'll have to repeat the process for all the topics, and the word that has the higher frequency for any topic is going to have its topic label changed to that.